Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. So we are from group 5. So today we will conducting experiment 6, which is Bourdan tube pressure gauge. Before I start the introduction, let me introduce my group member. First is Nur Atika Syaira binti Uyub, Nurul Hazmi Rahani binti Haznan, Nurul Nadra binti Zuhairi, and me, which is Nurul Natasha binti Nurzain. Okay, the objective of this experiment is to calibrate a Bourdan tube pressure gauge using that weight, to compare experimental result with theoretical value, and to establish calibration curve of Bourdan gauge. In this experiment, we need to calibrate the Bourdan tube pressure gauge by mounting the transducer in closed vessel with a piston at one end called a dead weight tester. The weight tester provided were in various standard weight. Nowadays, Bourdan tube pressure gauge are most widely used because of their reliability, compactness, low cost, and easy to use. It's widely used for steam and compressed gases. The pressure indicates the difference between the system pressure and external pressure and usually referred to as the gauge pressure. Experiment is conducted successfully as true pressure, which is standard known input, is almost the same as the pressure recorded the output. The input reading is the weight on the piston produce a known pressure in the vessel equal to the weight divided by the piston area, while for the output reading can be obtained from the pressure gauge. So the theory, instrument calibration is one of the most important processes for ensuring instrument accuracy. It is process configuring an instrument to provide result within acceptable range. Dead weight calibrator used to impart no weight to a fluid in order to test accuracy pressure gauge reading. Various type of pressure measurement instrument is used to measure the pressure intensity at any point in a static or flowing fluid. The Bourdan gauge is the most popular pressure measuring device for both liquid and gases. It can be connected to any source of pressure such as pipe or vessel containing a pressurized fluid. The Bourdan gauge is fitted with a transparent dial which lets you see the internal working of the gauge. The gauge consists of a thin wall closed-ended tube which is oval in cross-section. This tube is bent through an angle of about 2700 along its axis. The open end of the tube is welded to a hollow mountain block which allows the pressurized fluid to reach the tube. This causes the pressure from the source to transmit directly to the inside of the Bourdan tube. The applied pressure causes the oval tube to become rounder since a round cross-section has the maximum area for a given circumference. As it becomes Bourdan tube tends to uncurve which causes its free end to move. So in order to obtain very accurate pressure measurement, it is essential to regularly recalibrate the gauge. This is because the tube tend to become weaker with extended use. The usual procedure is to apply a known pressure to the gauge using a device called a dead weight calibrator. The normal calibration procedure is to load the gauge for known pressure using a dead weight calibrator, including a liquid of known specific gravity. Use water as the liquid. This dead weight tester uses a simple piston and cylinder arrangement to provide a source of pressurized liquid. In the experiment, water will produce a better result than oil, which is transmitted to the gauge. That's all from me.
Hi and Assalamualaikum. My name is Nurul Nadra binti Zulkhairi and I will be presenting about the methodology and the apparatus. The apparatus that will be needed in this experiment is a Bourdan tube pressure gauge, dead weight, and the piston. So this is the procedure proposal that our group made. So we get into the methodology. These are the methodology of our group in this experiment. The apparatus was set up as in the figure. We must ensure that the test gauge reading at 0 and 1 kilogram piston was put into the Bourdan tube pressure gauge. The piston is rotated in order to remove any bubbles present. The reading on pressure gauge is taken while there is no weight on top of the piston and after the system is stabilized as the first reading. A dead weight, which is 0.5 kg, is placed on top of the piston and the reading on the pressure gauge is recorded. The weight of piston is increased by 0.5 kg, increment which equal to 1 dead weight. The reading on the pressure gauge is recorded as 0.5 kg, weight added to the piston until the total is 5 kg are added. The weight are unloaded from the piston by decrement of 0.5 kg. The reading on the pressure gauge is recorded every time the 0.5 kg weight is removed from the piston. Repeat the step 2 until 6 for 3 times to get the accurate data by having average value. All data has been recorded in a table.
Now I will explain about the result and calculation for experiment 6. The value for piston area that have been given is 317.31 mm square and the weight of plug and platform is 1 kg. Before we do the calculation, the unit of piston area is must be meter square. So we do 10 reading and every reading the mass added is 0.5 kg. We need to calculate the theoretical pressure by using the formula F per A, where F is the weight in unit kilonewton and the A is the area in unit meter square. After that, we calculate the experimental pressure value we can measure it by using the calibrated pressure Bourdan gauge in the unit kilonewton per meter square. We do the repeated reading, at least 3 reading, and we calculate the mean of the reading, the increasing order of the weight and the decreasing order the weight. And after that, we calculate the percentage of error. The percentage of error is the formula is the pressure, theoretical pressure minus with experimental pressure divided by theoretical pressure modulus times with 100%. After that, we can get the percentage of the error.
Okay, for the discussion for experiment 6, question 1 asks us to calculate the percentage of relative error for the theoretical and measured experimental pressure gauge, which the percentage of relative error in percent is given by the formula P measured minus P theoretical over P theoretical times with 100. So in this experiment, the pressure measured is the loading pressure and the unloading pressure, or also known as increasing pressure and um, decreasing. So the P theoretical is given by the formula F over A in kilonewton per meter square unit. So in order to calculate the percentage of relative error, first we find the true pressure exerted by the piston, which we use the formula mass times with 9.81 meter per second square over area. So we got 30.9 kilonewton per meter square. While for the true pressure exerted by total mass, we calculate using the formula total M, which is the weight plus piston, times with 9.81 over with area, we got 46.4 kilonewton per meter square. So those are both true pressure exerted by piston and true pressure exerted by total mass. And then we calculate the average reading by calibrated pressure. We add all the pressure and we divide it by 3, and then we got 30.3 kilonewton per meter square
And then we are able to calculate the percentage error by using the value that we just calculated just now. So for the loading percentage error, we got 34.7%, while for the unloading, we got 13.8%. Okay, then for the question 2, they ask for the source of error and method to minimize the error. So the errors are the vibration on the gauge gives a negative impact on its accuracy, which the vibration causes difficulties to read the pointer on the dial, which eventually the vibrations eventually move a pointer off zero, producing inaccurate readings. So the method to minimize that error is to use a liquid fill case. Is the most convenient and cost-effective way to protect pressure gauge from vibration. So the second error is the cardinal point or division marking on a dial face of a Bourdan tube pressure gauge can be separated by a large amount, making it difficult to read the pressure precisely. And then the method to minimize the error is the pressure calibrator should be adjusted so that the applied pressure is set to the cardinal point on the pressure gauge. So question 3 is about the repeatability and accuracy of this equipment. For repeatability, the equipment was displayed by repeated times under the same condition, such as the mass added by each time. This is due to the condition of the Bourdan gauge can be regarded as a device that is sensitive to the surroundings, especially the temperature fluctuation. So the average reading is needed. From this experiment, the given percentage error by comparing both experimental and actual results is given by the value 34.7%. So with this significant value clearly shows that the experiment conducted might experience some inevitable errors or fluctuation. In terms of accuracy, for accuracy the experiment is repeated several times to get the average reading in order to obtain the most accurate reading. When the mass was added to the piston, the dead weight pressure gauge calibration responds slowly and results in the delaying, which is corresponding to the changes of pressure as well as the friction. So to sum up, even though the accuracy of the Bourdan tube pressure gauge does not reach 100%, by repeating experiment 1 to obtain the average reading, the result obtained will be more accurate and more reliable. And then for the conclusion, in conclusion, the value of percentage error for loading ranges from 16.44% to 5.27%, while the value of percentage error of unloading is in the range of 15.38% to 5.27%. Excuse the comma. This is due to some experimental errors, which are a combination of systematic and spontaneous errors that happen during the experiment. Thus, we must repeat the experiment several times to find an accurate estimated value. And then that is all from our group for experiment 6. Thank you.